Okay, so the problem that we're looking at today is the USACO 2024 January contest silver problem 2 of potion farming. So you can pause the video first and look at the problem yourself. Okay, so it's quite short. Basically, you are given a map with n nodes, and then it's a tree, and then some potions will appear in some order on all those nodes, and then you're trying to traverse the entire map from starting from point 1 as the root, and each time, each traversal, you go from point 1 to one of the leaf nodes. And then along these traversals, before each traversal, a potion will appear in the order given, like with the array P. And then if you happen to pass by a potion in this traversal of yours, then you collect that potion. However, every potion disappears after this traversal is done. So before the first traversal, a potion appears on node P1, and if this traversal does go through node P1, then you basically collect this potion. And then the second traversal, potion appears at P2. However, when you do the second traversal, the potion at P1 disappears, even if you didn't collect it on the last traversal. And each traversal is from root point, which is node 1, to any leaf node. And each leaf node is only traversed once. And now you're trying to determine the maximum amount of potion that you can farm or pick up from the map from doing these traversals. So you can pause the video once again and think about this yourself. Okay, so since it's a tree and you're trying to determine the maximum value is obviously a tree DP problem. And I'd say this one is actually what I expect silver problem to be in difficulty for a January contest. It's not too hard, but not too easy, just like the February one of this year. Okay, anyways, back to this problem. It's a tree DP. So how do we maintain this? Well, first of all, notice that we know exactly how many traversals we'll be doing. It's just the number of leaf nodes in this map, right? Obviously. So we actually only care, say there's m leaf nodes in this graph, then we only care about the first m terms of P. And then we realize that the order of P for the first m terms doesn't even matter. Because if you think about it, if we draw a graph, because if we think about this, say we have a root and then we have a few leaves. Let's just draw it as a binary tree, even though it's not. The order of the traversal is arbitrary. We can go in any order we want. So the order that the potions appear really doesn't matter. Say in the second traversal, a potion appears right here, and the third traversal, a potion appears right here. We can just change the order of these two, the order you do these two, and it wouldn't even matter at all to the answer. So what I'm basically saying is, all we have to keep track of is how many times a potion appears on each node in the first m traversals, and m equals the number of leaves. So all we have to keep track of is how many times a potion appeared on a certain node, and we don't need to know the order of those because we can change the order of the traversals as much as we want. And now we can simply maintain this with a tree DP. And here is my code. Basically, sol is a solution function, and then basically you return, it's a pair function, so you return two values. The first one being how many traversals in this subtree has already received a potion on the way down, and what is the size of this subtree? No, not actually the size, but the number. What is the number of leaves in this subtree? So we return, the first is how many leaves have already received a potion on the traversal visiting it, and SD as how many leaves are in this subtree. So for each of the X, obviously you traverse every single one of its sun, and then you add up sum being the total number of leaves that already have a potion, and SD is the total number of leaves. And CX is a bucket we keep track of that maintains how many potion appears on node X in the first M traversals. So the first M term that P, actually it's num. Num is the number of leaf nodes. So in the first num terms of P, how many potions appeared on node X is keep track of in CX. And then basically notice that the total amount of potions that we can receive from traversing all the leaves that resides under X subtree is the minimum value of either the number of leaves in X or the amount of potion or the amount of leaves that already have a potion plus the number of potions that X has, whichever is smaller of these two, obviously, right? And then the number of leaves in X's subtree is just the sum of the number of leaves in every single one of X's sun's subtree. And then the answer is just simple, and this is just a classic bug checker. However, we do have to note two details, actually just one. It's the fact that not every node with an in degree of 1 is a leaf because, well, the root might have an in degree of 1 and it's not a leaf. So first of all, when you're counting the number of leaves with num, you need to be aware of that. And you also need to make sure that you don't return at 1 because it has an in degree of 1. X is not equal to 1. And yeah, after that, this code is quite simple and straightforward. And I will be posting this in the comments along with all the explanations in the beginning of the code. Okay, so let's come back to the question today. The potion farming is basically a simple tree DP problem where you just combine the sub-problems from every single subtree of X to find the total answer for X, and then you just recursively solve the whole problem for the entire graph. And the most important notice for this whole problem is that the order the potions appear doesn't really matter. We just have to know that the only terms of P that we care about is the number of leaves, because we can traverse the leaves in any order. So really the order of the first num terms of P doesn't matter. So hopefully after this video, you know how to solve this USACO 2024 January contest silver problem 2 of potion farming. I hope this video helped. Thank you for watching, and I'll see you next time. I did absolutely nothing today for the grind. That was the end of the problem review for this problem, so you can go ahead and click out of this video if you're just looking for the solution to this problem. And the grind report for the day, I did absolutely nothing. Actually, I did something. I tried to do the homework for the class that I was taking, and the problem is also happened to be about a tree problem, which is a lot like this one. However, it's way more difficult. So let's go on Luogu and take a look. So it is the NOIP 2012 of epidemic control. You can try to read this problem, but it's very badly translated. Actually, this one is actually okay. It doesn't matter. I scored a 60, so not good. I'm still trying to debug it. Since our teacher already went through this problem in the class, I really should be able to solve it by now. But yeah, I know my code. The central idea is correct. The algorithm is correct. It's just there's got to be some kind of a bug in here. And yeah, all I did was write this today, which is basically absolutely nothing considering it's a Sunday. I should really be doing a lot, but I did not do a lot. It doesn't matter. Okay. I really need to lock in. At this pace, I'm not even going to get platinum next year or the year after that. So, yeah, well, I'll lock in tomorrow. There's always tomorrow. See you tomorrow.